My name is David Traxler. I'm with Pinnacle, and I want to thank you all for taking the time to come this afternoon. I want to thank the VMware team for being here. You've got a large contingent of Pinnacle folks that are here and VMware people that are here, and there's a small group of customers that are here. So we appreciate you guys taking the time out of the day to come. One of the things we were talking a little bit earlier, I didn't get a chance to visit with you, we were just talking about what we were trying to accomplish today. And I'll use my vernacular, but one of the things we're trying to do is put a little bit more meat on the bone when it comes to, how can we help educate ourselves and our customers around some of the new technologies. So that's one of the objectives that we had today. I'm going to turn the mic over here in just a minute to Will. So a lot of you may know Will Maker. But before we do that, I just wanted you to know we've got a group of people that are on live cam that are, I don't know how many people that we have, and Maggie, do we have any count as to how many people we have on live cam?
Last time I checked, it was around.
Oh, awesome. Well, that's fantastic. We were out there, it is here, it was great. So, again, I want to thank you all for coming. We're going to be very, very casual today. There's food in the back, there's drink in the back. Logistically, I think the restrooms are directly in the back. We're going to have two topics we're going to talk about today. We'll take a break between those two. So be very casual. Please ask questions. And that goes for the Pinnacle folks as well. Will the people on the live cam have the ability to ask questions as well? Where will those come in?
They will come into the live chat, and Ava will have those. Ava in the back right here will
okay.
She'll pop up and let us know when they come through.
Okay, great. So for our speakers, there may be some questions that come in over live cam, and you'll get the nod from back in the back. Will, Maggie, is there anything that I've forgotten just from a logistical standpoint? Okay, we're all good? Well, again, I just want to thank you all for being here. You'll learn a lot more about Pinnacle while you're here. There are a lot of us here. We've got a pretty good contingent of folks from the office that have come out this afternoon. And since there's two plants that are sitting here this afternoon, you'll have all the attention that you could garner. So thank you again for being here. And I'm going to turn the podium over to Will, and he'll kick us off from there. Okay? Thank you so much.
Hi guys, I'm William Maker. I'm a pre-sales technical architect at Pinnacle Business Systems. I've been with the company for about 3 years. So part of my job is to work with customers to design solutions using hardware and software to solve business challenges. But another aspect of my job is to stay up to date on newer technologies, kind of where the IT industry is headed as a whole, and how we can better educate our customers on newer technologies. So as part of that, we got with our marketing team and the VMware group, and we wanted to get some guys out to talk about Workspace ONE and NSX. Workspace ONE is kind of the direction that people are moving as far as an application presentation and virtual desktop type software for you to be able to work from any place using any device. And NSX is centered around network virtualization and allowing you to create application continuity and more security within your IT infrastructure using networking equipment inside the hypervisor. So I'd like to thank the VMware guys for coming out today. We have Brian and Jody that are presenting today. I think Brian's going first, so I'll turn it over to you. Thanks so much.
Okay, we'll jump right into it. I'm going to plug in. We don't need to do that. It's a small group. Let me plug in my laptop right up here, and I'm going to show you. First of all, I don't have any slides, right? So I hate just monologuing through PowerPoint slides. So everything that we're going to do today for the end user computing workshop is going to be completely just demo purposes. And so I'm actually going to log in and show you how we use these technologies at VMware in a completely real-world scenario. But by a show of hands, by the way, if you guys used virtual desktops in the past, have you used VDI, you're using it today, what's your deployment? How many virtual desktops? 120? That's okay, that's sizable. And 150, okay. Very good, very good. So let me log in. So right off the bat here, I wanted to demo a new way of doing applications, right? So we're going to talk about virtual desktops, and we're going to talk about how we can do that today. But what you see up here on the screen, this is just a login screen, and this is just a web page. This is literally just a web page. I'm going to log in with my account. if I can type my password correctly. And what you're going to see here, like I said, you've got to type your applet, or you've got to type your password correctly. That's the hard part. Okay, third time's a charm. It's always more difficult, you notice, when somebody's looking over your shoulder when you're trying to type in a password. So like I said, what we want to talk about today is a completely new way of application delivery. This is called Workspace ONE, or a Workspace portal. You can see on here I have some virtual desktops. So yes, VMware still does virtual desktops, and there's use cases for that, right? In a hospital type or a healthcare type of facility, we work a lot with school districts, right? If we have 0 clients or thin clients, and I have a large a large student lab, right? The idea of it being able to spin up 100 virtual desktops or 1,000 virtual desktops. We still do that, and there's still a lot of use cases around that. Like I said, we're going to touch on that today. But what I wanted to demo to kind of start out with is a completely new way to look at applications, right? So this is very application-centric. When I log into my portal, I see not only virtual desktops that I'm entitled to log into, but I also see applications. And let me talk about a couple of different types of applications. So everybody knows Microsoft Office, right? Our core productivity apps. I'm just going to launch one of these as a demo, right? And I always joke that this is the worst demo in the world because you've seen Microsoft Excel before on my Windows notebook. This is a Windows 10 notebook that I'm using. So the trick here is that I'm actually not running it locally on my Windows 10 desktop. I'm connected to one of our VMware demo environments, and this server, this demo pod, is literally, it's halfway across the country in San Jose, California, right? So I'm connecting over the internet, just over our hotspot here, literally halfway across the country, and now I'm interacting with this application in San Jose, California, right? I didn't launch a virtual desktop. I didn't have to log into a Windows 7 or a Windows 10 virtual desktop. My use case here, I just need to be able to get directly to an application. This is called the application hosting model, right? So this is what we're seeing more and more of today, right? It's more application-centric. The idea is I have all of my apps that I'm entitled to in this central consolidated portal. Today, the world that we live in, it's more than just Windows applications. The other thing that we're finding is there's a lot of web-based applications out there. An example of that would be SaaS-based, software as a service. Let me give you this demo really quick, because here's an example of Office 365, right? This is probably the most prevalent SaaS-based application out there, right? I don't know if you guys are doing Office 365 yet, but it's just a web page, right? Or at least to get to the web apps. So watch really carefully, right? Because this is going to happen fast. But you see that I'm entitled to use some of these Office 365 web apps. And what I'm going to do is click on it. It actually opens up a new tab in my web browser. And you see the URL. It goes to Microsoft Office. And then it forwards me to office.com. Now the magic here was that it seamlessly authenticated me into Office 365, right? It says, hey, good afternoon, and it shows my username, shows my account here, all of that good stuff. And then from here, I can click on any of the Office 365 web apps and use these web apps. So this is an example of a SaaS-based application. And again, the trick here, because I'm already authenticated to my applications portal, we know who the user is, right? So there's an element of a single sign-on type of a capability here. On the back end, we'll geek out a bit. So the back end technology here, we're actually using SAML-based authentication to pass a security token to Office 365. So there's no clear text usernames or passwords that I'm storing on behalf of the user. This is a truly single sign-on type of an experience. Again, we're seeing more and more of that today. The use case here is, why would a user need to boot up their virtual desktop to get to a web page, right? You can see the URL that I'm interacting with here. At this point, everything I do is on office.com, right? So I'm using 0 of your backend infrastructure, right, to support this user's application session. That's a cool idea, right? All that user needs to do their job is a device, an internet connection, and then that external web app. And what I want to do, I just want to centrally manage their entitlements to all of these different applications. I've got JB here. I want to introduce JB because he's one of our end user computing specialists. You notice I'm doing the demo from a Windows 10 device. And I told you this is the worst demo ever, right? Because launching a Windows-based application on a Windows device, we've seen that before. But again, because it's a hosted application, JB has this iPad here. So I could launch a Windows-based application on an iPad. That's traditionally not a VDI use case scenario, right? Like I wouldn't want to launch my Windows 7 virtual desktop on an iPad in order to get to a Windows application. I just want to get directly to that application, right? Or in this case, this external SaaS service. So the idea is that it's a seamless experience for the end users, right? Regardless of the device they're on. And really, if you take that one more level, regardless of the location, right? They could be remote, they could be in your building, they could be anywhere in the world. As long as they have an internet connection, they can get to their applications. Yes, sir, question?
Question about your web-based apps.
Yep.
So the web-based app requires that you run it on a certain browser. Is there a...
That's an excellent question. So actually, that's where I was going next. So we have that all the time, right? So legacy web-based applications or internal web-based applications, it might require a specific version of Internet Explorer and the usual suspects. It also requires this version of Java, this version of Microsoft Silverlight, or this version of Adobe Flash. So let me give you an example of that, right? I'm going to launch this web browser. If you can see by the title, this is Internet Explorer 6.0. How old is Internet Explorer 6.0, right? So you guys are going to laugh at me, but obviously I don't have Internet Explorer 6.0 installed on my Windows 10 machine, right? But for that use case, what I would want to do is I can configure an application server in exactly the configuration that I need to run that app, right? It's got Internet Explorer 6.0 on it. And actually it doesn't, I'll go into that in here in just a second, right? But it's got the specific version of Java I need, or the specific version of Flash, right? And let me just prove this out. Here's, if I go to the help and the about screen, sure enough, here we are with Internet Explorer 6.0, right? So that's a use case where I have a legacy application that I need to deliver, right, to a Windows 10 device, or we could even launch this web browser, right, on JB's iPad back here. Again, it's device agnostic.
What if it was, this still kind of runs on your back end?
That's correct.
Okay. So what if you wanted a web app to launch on your, like you would Office 365, but only in Chrome? If you pass a token to it, then we'll say only open this web app.
Not necessarily, right? Because through the web access, the only requirement is an HTML5 web browser. And well, technically that's not even true if I'm just doing the pass-through authentication. But it's almost browser agnostic if you think about it that way, right? So no, not to that level of detail. What we go in mostly today is around HTML5 access. So I don't know if you noticed, but it actually launched the Horizon client on the back end. What I could do, I'll show you a demo of that here really quick, right? What I could do is actually just go directly to the HTML5 interface, right? So again, if you guys are using Horizon today, you've probably seen this on your connection broker. You have an option to log in just using nothing but web-based access. So I need to log in really quick, and of course I selected the wrong domain. Let me select the right domain name and the correct name. And there's an example of logging in with the HTML5 access, right? So you see, again, this is just a web browser. The difference here, because I'm going purely through the web browser, if I launch that same Internet Explorer 6.0 application, that actually shows up inside of the web browser, which is kind of a neat trick. There's just a warning that it kicked me out of my other session because I already had Internet Explorer open through the Horizon client. So this looks kind of funny, right? Because in this case, I have a web browser inside of a web browser, but that Windows application is actually running inside of my web browser right through an HTML5 session. So in this case, all of that, the only thing that user needs is literally an HTML5 compliant web browser to get to their applications.
So not IE6.
So definitely not IE6. Here, I'll show you a funny, here, if you have IE6, let me go to like a website like yahoo.com. We went to this earlier, right? So it starts complaining immediately like, hey, why don't you download Firefox, or why don't you download a more modern web browser? You can't use IE6 anymore. All right, so I'm going to close that. The only other full disclosure, right? The only other thing that I was going to say about the IE6 is we use another technology. We actually have to virtualize that application because you can't install IE version 6 on anything anymore, right? The backend application server that we're running in San Jose, it's actually, I think it's a Windows 2008 R2 server. Again, you can't install IE6, so we leverage another VMware technology. I don't know if you've ever played with VMware ThinApp, but that's the use case for that, right? Like I'd actually take and containerize that application so I can install IE6 on an older operating system, say like Windows XP, and then I capture that, and then it runs in a containerized sandbox. So now I'm able to take that application package and I'm able to put it on my Windows 2008 R2 application server. Yes, sir?
That was exactly the question I was going to ask. What's the difference between containerizing and stuff?
Yeah, so the difference is whether it's natively installed, right? So ThinApp is an example of an application packager, which means we've virtualized that entire application, right? And it's running in its own sandbox, right? So it's interacting with a virtualized file system. It's interacting with a virtualized registry. And the benefit of that is, again, now the underlying operating system, and specifically those operating system settings, become somewhat transparent to that application, right? Because it still believes it's running on that old Windows XP machine, right? Because that's what it sees when it's interacting with this sandbox. The other use case around that was traditionally, if I have application incompatibilities, right? I could use VMware ThinApp and actually run two applications side by side because they're both in their same, in an individual sandbox. And they're not actually interacting with one another, right? Even though they have conflicting DLL files, right? Or conflicting registry settings or something like that, right? The example there is like you cannot install, I came across an example yesterday. I can't install Office 365 with the full retail version of Office 2013. You can't do that. Microsoft doesn't let you do that from a licensing perspective. That's actually something that you could do with ThinApp, right? Because those two applications are not aware of one another. So the technology that we leveraged in that case to launch, again, here's this old Internet Explorer 6.0 web browser, right? We actually leveraged two things. I packaged it up with ThinApp to containerize it in order to put it on a brand new operating system. And then we're delivering it through, we call this application hosting, right? Or a Microsoft RDSH session to the end user. And there you go, there's my Yahoo webpage that pops up again, and it's complaining that, hey, you're using IE version 6, go get a newer web browser, you dummy. All right, so close that window. What I'm gonna do now is go back here to my web browser. So this is the Workspace portal. Again, the idea here is that it's a seamless user experience, and you're managing application entitlements now through Active Directory global group membership. And that's an important concept now, right? That's fundamentally different from the way we've traditionally managed applications, right? The way that we used to manage applications is a user would have a PC or a laptop, and I'd have to use a traditional PC lifecycle management tool like SCCM or Tivoli, or excuse me, not Tivoli, Altiris, one of those types of tools, right, in order to install an application for an end user. That's fundamentally different than adding a user's Active Directory global group or Active Directory user account into a global group, and then their application just automatically appears inside of my application portal. And again, it's that seamless experience, right? The idea is that that application portal looks exactly the same, whether it's up here on the screen in my web browser on my Windows 10 device, or whether it's on my Android device, if it comes up, there you go, or whether it's on JB's iPad over here, right? The only other time that I'm gonna show, and we won't show it up on the big screen because we're not mirroring JB's iPad, but the other use case here, again, we have more than just Windows apps that we're working with today, right? We showed a demo of launching a Windows app, we showed a demo of launching a web app, but now we also have native applications to an iPad or an iOS device, right? So we could also assign those apps into the user's Workspace portal, and this is where the MDM or the mobile device management technologies come into play, right? So the idea is I now need to manage that mobile device, and I can actually push or publish applications, right, to that mobile device, in which case if it is a native iOS app, or on my Android device, if it is a native Android app that I download from the Google Play Store, it can also show up in this web portal, right? So it's a single place for the users to go to get to all of their applications. What I'm going to do next here is launch a virtual desktop. So you guys use virtual desktops today, so you're familiar with this piece of it, right? So nothing earth-shattering yet. I'm just going to log into a Windows 7, a plain Jane Windows 7 virtual desktop. But I'm going to show you some of the newer capabilities that we have around managing applications, even inside of a VDI session, right? So let me take one step back. Usually, my design goals in a VDI environment are to do non-persistent desktops, right? Because that's usually where I get the best leverage from a management perspective over that desktop environment. What I want to do is create a base image, and I want to manage that, and I want to manage it well, right? That means that base image is fully compliant with the latest Microsoft hotfixes. It's fully compliant with your organizational security policies. It has the latest software patches on it for whatever software I happen to have baked in to that base image, right? And what I want to do is spin up a pool of virtual desktops from that base image, right? I can spin up a pool of 100 virtual desktops. I can spin up a pool of 1,000 virtual desktops. In that case, I'm managing one instance of the Windows operating system, right? I don't have 1,000 instances of the Windows operating system. I have one instance of the Windows operating system, and I have a pool of virtual desktops that are all booting off of that common image, right? So that's my design goal. From a management perspective, that's my design goal. Now we know that we're going to have scenarios where we have different users that require access to different applications, right? So again, this applies to this pure VDI scenario, but here's the tools that we have today to leverage the management of that VDI environment. I'm bringing up here the Windows add remove programs, right? And I do that because I wanted to show you this. I wanted to show that there's 38 applications that are currently installed on this virtual desktop. Okay, remember that number, because I'm going to launch a shortcut. What I've done is I've created a shortcut script here, and the only thing that this shortcut does is it adds my user account to an Active Directory global group that entitles me to additional applications. And it takes just a second to attach these apps, but if you watch the screen, I go from a small number of applications to all of a sudden, bam. Now I've got all of these additional apps that are available on my virtual desktop. That's a neat trick. Let me go back here to the add remove programs, because I want to do a quick screen refresh. I went from 38 applications to 87 applications, right? And it appears that they're just natively installed on that virtual desktop. So this is how I've solved the problem today of being able to toggle on or off an individual application inside of a virtual desktop, either for an individual user or for a group of users, right? And again, my design goal there is I know I'm going to have different use case scenarios with different groups of users that need different applications, right? And this is how I can do that today. I'm going to do, just to kind of complete this demo, let me go ahead and do one more thing, because I can actually detach those applications just as easily, right? So if you watch the screen, now that I've removed my entitlement to those applications, and again, the only thing that shortcut script does is it reaches out and it removes my account from that Active Directory global group, so I'm no longer entitled to use those applications, and there you go, they're gone. They don't show up on my virtual desktop anymore, right? To me, that's a revolutionary capability in how we manage virtual desktops, right? The idea just to toggle on or off an application. If you looked at how we've had to do that historically, we may have had to spin up multiple desktop pools, right? Like maybe I had a single base image with this group of applications in it, and I could spin up 20, 30, 40 virtual desktops in that pool, and then maybe I would have a different base image with a different set of applications in it, and I could spin up 20, 30, 40 virtual desktops in this pool, and you saw the problem, right? I had sprawl, or I had too many base images that I was trying to manage. I don't want to do that anymore, right? My design goal is to have one base image and manage it well, and everything else is just applied, right, through the application layering. The name of this product, by the way, on the VMware side, it's actually called App Volumes. So it's a form of application layering or application virtualization. The way we do it on the back end, it's kind of a neat trick if you think about it. The way that we do that on the back end, you actually have to have what's called a reference virtual desktop and it's just a clean virtual desktop, right? So nothing special about it. And I'm actually going to install that application. Now, the way that the application gets installed is we mount a VMDK file, another virtual disk, to that virtual desktop. And through the magic of an agent, while that application is going through its installation process, it actually gets written to this virtual disk, this separate virtual disk. Think about it kind of like a sidecar, right? So now I've got the entire contents of that application, right, including all of the executables or the DLL files, the registry settings that it needs to work. I've got that self-contained in a separate virtual disk, right? And that's the magic that you just saw here, right? The only thing that happened on the back end, on VMware's side, is I connected that virtual disk, or I attached that separate virtual disk to this running virtual desktop, and through the magic of the agent, it seamlessly merges in all of those file paths, all of those registry settings, everything that's in that application to the running virtual desktop, right? So Windows doesn't know the difference, right? To Windows, it just looks like that application has always been natively installed. I'm gonna do one more thing here just for fun. So one of the things that we like to demo, I don't know if you guys are doing any of this. Do you have a requirement for any, high-end graphics capabilities for your users in the healthcare space? Okay. This is typically for a subset of users, right? This is kind of a niche scenario where I'm not going to assign high-end graphics capabilities to 100% of my users, right? But I like to demo this because it kind of shows that there's no limit to what I can do today, right, in terms of the horsepower that we can build into these virtual desktops. This is an NVIDIA grid demo, right? So there's a full disclosure, right? There's actually an NVIDIA GPU installed in our server on the back end. So when I launch this virtual desktop, I can do things like 3D rendering or AutoCAD or Google Earth, right? Google Earth actually requires some 3D rendering capabilities. So we can put high-end graphics cards into our servers today in order to support these use case scenarios, right? And again, I like to highlight that to kind of show out that there's no limit in terms of the use cases or in terms of the horsepower that we have today behind these virtual desktops. And that's cool. I like showing, like I said, you won't do that for all of your users, but that typically applies to a subset of our use case scenarios. All right. Any other questions as we go along here? We're going through this quick. I'm going to log off of my virtual desktop. The only other piece that we didn't talk about are some of the user profile management pieces. So let me just talk through that really quickly, because one of the things that you do, well, are you doing non-persistent virtual desktops today? Are you using any sort of like user profile? Persona, just the view persona management? And how about you guys? Just desktop pools? Okay. So the design goal is that I certainly want to try to use non-persistent desktop pools wherever I can. That's my preference looking at virtual desktops today, right? Because it allows us to do so much stuff. But the one thing that I have to do when a user logs into that virtual desktop, I have to make it look like their virtual desktop, right? So one of the things I want to do is capture their profile settings. And this is where I get a lot of bad looks, right? Because I kind of equate it to like Microsoft roaming profiles back in the day, right? And everybody hated roaming profiles, right? Because they were slow, it took forever to log in, it had to pull my entire user profile down off of the server. So this is not that. What we do today is we actually have an agent that runs in the virtual desktop that will systematically capture all of the application settings that user is making, right? All of the operating system settings, all of the application settings, any user-specific settings that user needs, we're gonna capture it, and we store it in XML data, and it actually exists on a file server. Now, the benefit of that is that those application settings are applied in real time, right? So this is not one of those scenarios when they log on, and I have to pull down all of their application settings or their entire profile off of that file server, like in the old days of roaming profiles, right? I'm able to programmatically and conditionally apply user profile settings. An example of why I would want to do that, the usual case here is like printer mappings. So I don't know if you have this use case scenario, right? But it's possible that that user may roam throughout your campus or throughout your building, right? So when they're in this room or this area of the campus, I want to map them to this specific network printer, right? A network printer, that's an example of a user profile setting. Today, I can programmatically apply that specific setting based on a set of conditions. So in this example, the use case would be, like maybe the IP address of where they're connecting from, right? If they're at this IP address, they're from this lab, so connect them to this printer. If they're from this other range of IP addresses, they must be working from home, right? So I don't want to connect them to the printer in the building, that type of thing, right? But I could actually conditionally apply any type of profile setting that we need to, right? So it gives us a tremendous granular capability over how I'm managing user profiles today. That also holds true to the hosted app model, right? So if I launch, I'm going to launch this again. If I launch, say, Excel 2013, right, off of my, I don't know what that is. If you launch Excel 2013 off of my hosted app server, this same agent is running on my app server. So if I've put specific configuration settings in Microsoft Excel that I need to persist from one session to the next, that actually applies to this hosted app as well. Even though the hosted app is not running on a Windows 7 virtual desktop, right? It's running on a Windows 2008 or a Windows 2016. We can do 2016 today, right? It's running on a Windows 2016 application server on the back end, right? But those same application settings persist from one environment to the next.
Is that a different name? Is that no longer persona? Or
so you still have persona management with View. The difference is the conditional access. So that requires a different agent that actually runs in the virtual desktop. And the VMware, the product name associated with that is UEM, or the User Environment Manager. It comes with app volumes. So app volumes is the piece that we just demonstrated, right? Where all the applications just magically appeared on the virtual desktop, right? So that's actually built in now to that product, or at least from a licensing perspective, it's built into your app volumes license. And of course, there's different editions of Horizon, right? You get Horizon Standard, Advanced, and Enterprise. With Enterprise, all of those capabilities are available, right, in that top level in the Enterprise edition, right, such as app volumes and the profile management piece. Cool. All right. Other questions? I'm trying to think. JB, did you want to highlight anything? I know we were passing around the iPad and kind of demoing the different capabilities from there.
Saw the user experience being the same.
Cool. Cool. This is a small group, guys, so we can keep this as interactive as you. Well, I'm curious, what version of Horizon are you on today? 6.2.2. Okay, so that's fairly recent, actually, right? So Horizon 7 has been out for, gosh, what is it, a year, just over a year? I'm trying to remember when that initially came out. So if you're on 6, you have the application hosting capabilities. That feature was announced with Horizon 6. And again, that's big news in my opinion, right? Because we're seeing more and more of just the application delivery piece. So the idea of, I can launch a virtual desktop if I need to, or I can just launch an individual application. JB, I guess we should touch on the title of this presentation, right? Was Workspace 1. So I want to touch on that name for just a minute, right? Because what the Workspace 1 product set includes, and first of all, remember, this is just a branding thing from VMware, right? So the Workspace 1 suite includes both AirWatch components, that's the MDM or the mobile device management components, in addition to the Horizon pieces, right, that we demoed here today, right? So it's just a way to package together this complete set of end user computing technologies from VMware, right? And like I said, the use case there is your users are mobile today, right? Whether they're executives that are walking around with their iPads, or whether it's just people that you've assigned mobile devices to, I know I need to manage that mobile device, and I know I need to provide application access to that mobile device. And so that's why the products go hand in hand, right? And if it makes sense, talk to this man right here, right? Because you can actually combine both the MDM or the mobile device management capabilities and the Horizon capabilities under one licensing model. And that's this Workspace One name, right? Again, that's just a branding name from VMware that encompasses all of these different types of technologies. Cool. I'm gonna wrap there unless there's further questions or further things that you guys want to talk about.
Right, good.
Cool. All right. Well, we appreciate your time today. We'll be here afterwards also if you just want to talk shop, right? And we can talk through like your specific use case scenarios and that kind of thing.
Thanks,
Cool.
Brian.
Yeah.
Thanks, appreciate it.
Yeah, thank you.
Hey, we're gonna take a 10-minute break. We've got hors d'oeuvres back in the back, heavy hors d'oeuvres, as a matter of fact. Let me get right here. Heavy hors d'oeuvres back in the back, and cocktails and stuff to drink over here to this side. So we're gonna take 10 minutes, and if you guys will come back in 10 minutes,
got it.
and we'll get started on the next session. Okay? Thank you.
Just you.
Okay, hey, everyone outside, we're going to get started again. Did you get something to eat?
I did.
Good.
I ate pretzels. Yeah. Was that a big lunch? I had a big lunch.
Oh, yep. There's a lot over there. You guys ready to get started?
I can probably handle some wings after this.
Yeah. It looks good.
Wings good?
Okay, thank you. Food good? Great. All right, hey, Jody, right?
Yes.
We're going to cover NSX. That'll be the next subject that we cover this afternoon. Thank you again. And again, plenty of food, drinks in the back. Thank you.
Cool. Thank you. Quick introduction. So yeah, you guys, where's she at? Here we go. Better? Yeah, you guys finish up with Dilbert because I'm turning them off in a minute. So, all right, so yeah, I'm Jody Clark with VMware. I'm NSX SE. So Brian actually covers kind of all things VMware. He's a core SE. I specialize just on NSX. So I don't have a live demo because virtual networking is not fun to demo live, right? It's, hey, look, I created a logical switch and I can ping. Yeah, I created a router and I can ping. Yeah. So yeah, this lends itself usually better to a whiteboard. So usually if I come out and visit with customers, I do a lot of whiteboarding. That doesn't lend itself well to live streams. So PowerPoint it is. I got about 300 to get through, so if you guys would sit down. I'm kidding, I have less than that. So start off with the software-defined data center, right? So really, with NSX is our network virtualization and security platform. Really good to understand how it fits into the larger structure of the VMware software-defined data center. Hopefully, your account reps are out talking to you about this. But if you look at, what are supposed to be the data centers of tomorrow, the Google, the Facebook, the Amazon, right? We see about them, read about them, and, publications and whatnot. They're the fastest, most resilient, and, all these great accolades we throw at them. They build these huge, spine leaf architectures with, multiple paths and all kinds of delivery, and they run on white box infrastructure. But what's the advantage that they have that they can do all that? Well, the advantage for Facebook is that they just run Facebook, right? They're not running, Microsoft Office or Oracle or SAP or healthcare applications or student management applications or, whatever you guys are running, right? In fact, if you look at Facebook's corporate data center where they do all run all that, the network is just as legacy as yours is. So they have this abstraction, right? They have a custom application, they run it on top of a custom platform that they build that provides all of the functionality to that application that it needs. So I don't have to get certain functionality out of network hardware or server hardware or storage hardware. I just provide that through a platform and then I run any old hardware underneath it. So how can you guys benefit from that? Well, we're not providing a custom application and a custom platform with VMware, but we are providing a software-defined data center platform for the same levels of abstraction that Facebook gets out of their custom platform, right? So I've been doing this for a long time with x86, right? So vSphere abstracts functionality out of underlying servers and allows us to virtualize the server experience. So with NSX, we're going to do the same thing with network and security. So we're going to abstract layer 2 functionality, layer 3 functionality, firewall functionality out of underlying physical hardware, provide that through this platform, right? And now I can run maybe Cisco in one data center and Arista in another, or maybe I expand to a hybrid cloud, right? I can get similar functionality and similar services out of dissimilar hardware. So it starts to become less important that I run a certain manufacturer that offers certain functionality across the board, right? And then the same thing with storage, right? So vSAN for storage. So really all we're asking you to do is think about what if I could take the operational model of a VM, the ability to programmatically create, delete, snapshot, restore, vMotion, right? Do all of these things that I do with a VM. What if I could do that with my network and my server, my storage as well, all right? How much flexibility would that give me to span across multiple geographies, multiple data centers, cloud data centers, cloud topologies, things like that. So that's the software-defined data center. Any questions there? If there are, I will repeat them. Okay. So what is a virtual network? Let's take a look. We're going to dive just into the NSX, just to the network piece of the software-defined data center. Well, if you look at a traditional network, right? I've got a couple of web servers here, a couple of web VMs. They connect to a layer 3 subnet. They communicate with each other across layer 2 services, right? Switching services. I connect all of my different layer 3 subnets into a router to get to the application tier, to get to the database tier. I've got maybe some ACLs or some firewalls that I go through to get in between different tiers or different VLANs. I do some natting there, and ultimately I route in and out of the internet to my user community, right, whatever. So a virtual network is the exact same thing. It's everything that you see here. It's just a software construct, right? Rather than receiving routing services from a router, we're going to receive it from a process that runs in the hypervisor. Similar thing for firewall and security. So I can kind of containerize this whole application, right, with all of the layer 2, 3 firewall services that it needs, and I can deploy it on any infrastructure in the data center. So if I start off with my existing network, right, to deploy NSX, you don't have to stand up a whole new infrastructure. You run it on top of your existing data network. I'm going to have some servers that are attached to that network, right? Hopefully everybody's running the vSwitch, right, the VDS, on top of our hypervisor. And really, I'm just going to add a new layer of abstraction for network services. So this is going to run across all of the hypervisors in my environment, and then I can take that little containerized network topology that I just built, and I can deploy multiple of those anywhere in my infrastructure stack, right? These can be for different security zones, right? So maybe this is like my DMZ, here's my PCI environment, here's my HIPAA environment, right? Here's my CGIS environment, here's my, my SAP environment, right? So I can kind of containerize those different environments, completely segment them, even though they all run on the same underlying physical infrastructure. Glad I didn't leave the top off that. All right, so what is a virtual network? It's all the services that you need, right? We've already talked about this. And in this case, I have 2 VMs that are going to communicate with each other at layer 2. Rather than going out to the network and belonging to a VLAN, I'm just going to provide switching services, and they'll communicate with each other without ever leaving the hypervisor. Now, you might say, hey, I already do that with a distributed switch today, right? And for the most part, you do. The difference is, with the distributed switch, I have to configure a VLAN in the physical network. I have to trunk that VLAN down to the host, and I have to create a port group that's backed up by that VLAN. So I need a physical network object to define what the layer 2 domain looks like inside of the hypervisor. With NSX, I don't need that. I just create what we call a logical switch, and it has its own layer 2 definition, right? If I have 2 VMs that are on different IP subnets and they want to communicate, again, I don't need to go all the way out to the physical network to hit a router to get layer 3 services. I'm going to provide layer 3 services through the hypervisor through network virtualization. So now I'm definitely not doing this today, right? So this is new. If the same layer 2 segment exists on different sides of the data center, right, the network services required are programmed into each host. So it's a distributed networking model, right, kind of like a distributed compute model. It's basically solving one large problem, but we're doing it through distribution of different services through different hypervisors wherever those services are needed. So in this model here, or this example here, VM1 and VM2 on different sides of the data center belong to the same layer 2 segment. And they need to communicate across the physical network that does not map that layer 2 segment through VLANs between ESX hosts. So how do we handle that? Basically, we use VXLAN, Virtual Extensible Local Area Network. We're going to take a layer 2 frame that VM1 is going to put on the wire. It's going to hit what we call a VTEP, or a VXLAN tunnel endpoint. At that point, I'm going to add a new header. So it's an encapsulation header. It's layer 2 over layer 3 encapsulation protocol. The destination IP address in this outer header is now going to point to the IP address of the remote VTEP. So all I need from the physical network is IP connectivity from this host to this host. And I'll use that underlay physical address space to route across my physical infrastructure and carry packets from this overlay IP space that is completely transparent to the physical. Does that make sense? Hope so. So these guys can be, on different servers connected to the same top of rack switch, and that'll work great, right? They can be on different sides of the data center, connected across the core, going across, different layer 3 domains. That'll work great as well. They can be in different data centers, right? So I can have a data center here in Oklahoma City, and I can have a DR facility maybe in Tulsa, maybe in Dallas, right? And I can extend that logical address space out to that remote data center just through the use of IP forwarding at the underlay network level. The only additional requirement I have is a 1600 byte MTU, because when I use VXLAN, I add an extra 50 bytes header to the IP packet. So, and that could even be out in the cloud, right? So we offer that today with IBM SoftLayer, with vCloud Air, with some of our vCloud Air network partners. I'll talk about this coming up. We made a big announcement with AWS. So pretty soon you'll be able to provision bare metal services in AWS and use the entire SDDC platform on top of AWS. Go ahead, question.
So, is it advisable to use jumbo frames and that way you have a much less?
So is it advisable to use jumbo frames? So technically, anything over 1544 is a jumbo frame, right? We don't need any more than 50 extra bytes. So I wouldn't say it's advisable to use, 9K frames unless you need, for some reason, 9K frames. Just make sure that there's 50 byte headroom there for the VXLAN protocol. So if you can do that off 1600 bytes, then great. All right. We can extend VXLAN or VNI or logical switch segments. These are all terms that get used interchangeably by VMware to confuse you. To define one thing, which is a logical network. We can extend on a one-to-one basis a physical VLAN to a logical network. So if I do have old Oracle databases that haven't been virtualized or other workloads out there that haven't been virtualized, but I still want to extend logical services to the physical VLAN, I can do that through bridging or vice versa, right? I can have VMs that belong to a logical network that receive some sort of service from a physical device on its own layer 2 segment. All right. So just a quick look at the gain and efficiency. Pretty common setup here. I've got two VMs. They exist on the same UCS blade, but different IP subnets. In order for me to allow these two VMs to securely communicate, I'm looking at least 6 wire hops in most instances. All right, so I'm going to go from VM1, I'm going to traverse my UCS fabric, I'm going to get out to a core, I'm going to go to a firewall where I apply some sort of security service. I'll come back to the core, back to the fabric, back to the blade I just left, and now I can talk to the VM that sits right next to me in user space, but on a different layer 3 IP segment, right? With NSX, because we have the ability to do routing, to do switching inside of the hypervisor, as well as we'll spend a lot of time talking about security, right? That's coming next. But I actually have the ability to perform all of these functions, and these two VMs communicate with each other without ever putting a packet on the wire, right? So large gain in efficiency here. Even if I'm going from blade to blade, like I am in the second model, I always do routing on my first hop host. So when I egress this first blade, all I need is the shortest physical path to the destination blade. So if those are two blades that are on the same UCS system, I can take the shortest path being across the UCS fabric. Make sense? Cool. So that's kind of the primer on the network virtualization piece. So there's 3 common use cases for NSX. One is multi-data center type scenarios, right? I want to have active data centers. I want to do hybrid cloud. I want to enable DR. So when I have a DR event, right, I can fail my DR systems over, and without having to re-IP, without having to make DNS changes, do all those things. So that's one. The network virtualization obviously plays very heavily into that. You can do security, the second use case, without doing any network virtualization. So I can run this distributed firewall that we'll start talking about on my existing VLAN-backed distributed port groups, right? Don't have to virtualize a single thing. Really, if I want to do the distributed firewall, I deploy one OVA. That's NSX Manager, right? And I can do that. Obviously, I can do both of them together, right? So I can do network virtualization and or security, or obviously the two of them together. And when I do that, that starts to play really well into the third use case, which is data center automation. Right, so if I want to create templates, blueprints for entire networks, right? Do self-service portal where users can go in and say, hey, I need to spin up a new environment. I need 3 web servers, 2 app servers, a database, a load balancer, different networks. I need routing, I need security. Right, if we want to enable functionality like that, and then all of that can be programmatically deployed through automation, then obviously both the network virtualization and security play pretty well into that. So, But yeah, getting onto the security piece. So James Clapper was testifying to Congress. He said we need to take our modern cybersecurity posture, both in the DoD federal space as well as out in the private civilian world, from where it's at, which is kind of a Titanic model, to more like a nuclear submarine model. And what he meant was that the Titanic had 3 compartments, right? And there was bulkheads separating those compartments. The idea was that if one of them was breached, the bulkhead would keep seawater from spilling over into other compartments and the Titanic would float. Obviously, you guys have seen the movie already. If not, I'm going to ruin it for you here. But the Titanic sinks at the end, right? The bulkheads were not sufficient to keep the seawater from spilling, and it sank to the bottom of the ocean. A submarine has better compartmentalization, right, and more reliable bulkheads. So I can take a breach in one or multiple compartments and continue to operate because I can contain that breach, right? So no security vendor can stand up here in front of you and tell you that, hey, you're never going to have another breach. But the idea is, once I take a breach, it's a race, right? Do I contain that breach first, or does that spread first? And then whether you win that race or not really depends on how many millions of dollars you have to pay to fix the breach, right? So how does that apply to the data center? Typically, we create a couple of zones or context or whatever you want to call them, right? We separate these, a lot of times by different compliance areas. So if I have PCI compliance, or if I have HIPAA compliance, or if I have some sort of NERC compliance, I'll create a zone for that. The problem with that is I only do security between zones. I do very little intra-zone security. So if I have 500 VMs in zone 2 and I have a breach of 1 VM, my exposure is really 500 VMs because all of my security controls are inter-zone, not intra-zone, right? Or east-west inside of that zone. So with NSX, with distributed firewall, with the ability to run a firewall on every VNIC, we essentially want to make every VM its own security zone, right? Every VM has to go through a stateful firewall to receive or send any packets across the network. So we want to go from something that looks like this, right? This is kind of today's data center. I create a perimeter security, and I say, if you're outside, you're bad. If you're inside, you're good. And the big reason I do that is because I really don't have any way to enforce anything inside. I have to kind of trust that it's good, right? This trust but verify model. So I'm going to trust you if you're inside, but I'm going to verify if you go in or out that you should be doing that, or that you're not carrying information that I don't want exfiltrated out. If we look at IT spend over the last 10, 15 years, it's grown, right? And it's kind of topped off, still growing a little bit year over year. Companies are still growing their IT spend. Security spend is increasing much, much quicker now, right? Kind of starting to do the little hockey stick thing. The only thing growing faster than security spend is number of security breaches, right? So we see about those, pretty much weekly now, right? If not daily, there's some sort of security breach, whether it's Target or OPM or, some sort of ransomware, WannaCry outbreak, right? It's becoming a pretty common occurrence. The problem, we think, is not necessarily that we're not spending more money, we're not buying good products, right? I can buy an ASA, I can buy a Palo Alto, I can buy a Fortinet, right? There's lots of good security products out there. The problem is really an architectural issue. It's that perimeter-based security. I haven't done anything to take that perimeter-based security, break it down, and apply it east-west inside the data center. So I don't really have an architecture, a security-based architecture, right? I kind of have a Great Wall of China architecture. So the solution to that is microsegmentation, right? We want to, and this has become a big marketing term, right? So everybody offers microsegmentation now. VMware first kind of coined the term, and then, other vendors were quick to follow. Now one vendor says they have nanosegmentation, which has got to be better than microsegmentation, right? Because it's smaller. So there is no RFC for microsegmentation. So it is whatever your microsegmentation vendor says it is. Just like cloud is whatever your cloud vendor says it is, right? It could be SaaS, it could be infrastructure as a service, it could be Amazon. So just make sure you know what the vendor is actually offering. Our version basically says that we have to have granular control over all traffic that ingresses or egresses any VM in the environment. We have to be able to centrally control that and distribute those policies out, right? The idea is to reduce the attack surface. We have to have visibility, right? If we don't have visibility, how can we have granular control and control something at that granular level if we don't have visibility into what it is we're doing. Obviously, we want to block lateral movement. And if you guys are familiar with like Forrester and their zero trust architecture, really we want to start to move to an infrastructure that looks more like that zero trust, away from the trust but verify. Traditionally, for a workload to receive security services, again, I have to go look for those services. Right? So my VM actually has to send a packet out to a perimeter firewall to get some sort of stateful or next-gen service applied to it. Anywhere that I can veer left or right before I get to that firewall is my threat plane. With NSX, however, I'm going to take that firewall and attach it directly to the VM. Any packet that ingresses or egresses, even before it hits the virtual switch, its virtual access layer, we're applying stateful services to it, right? If that VM moves, the policy, that stateful firewall becomes part of the VM state, so it's going to follow it wherever it goes. Again, this can be across the data center, this can be between data centers, it could even be to a soft layer or to an AWS, right? I'm going to take my security policy with me wherever I go. And if I turn that VM off, right, then the security policy just stops being enforced. So I don't have that big problem of rule sprawl and applying a bunch of rules that don't apply to traffic in and out of every firewall interface. Talked about that. So there's a big difference between physical firewalls, right? I'm not telling you to get rid of those. Keep buying those, put them at the perimeter, run your next-gen services, do your DDoS mitigation, terminate VPN tunnels for your vendors, and do all that kind of stuff there, right? These are high throughput and definitely very critical, mission critical. Not telling you to do away with those. You can do away with virtual firewalls. So we tried to do this micro-segmentation model with virtual firewalls, right? We took a firewall, put it on every VM, and sent all traffic through that firewall, thinking that this would make us more secure, but really all we did was kind of reduce our performance. These are generally like 2 gig devices. So I take a 20 gig host, put a virtual firewall on it, now it's a 2 gig host, right? So kind of that security versus performance trade-off. With distributed firewalling, you'll notice every VM has its own individual firewall attached to that VM. Runs at full line rate, right? And each of them have their own policies that are specific just to that VM. So if I have 1,000 lines of firewall code, but only 5 are relevant to this here, right? I only push 5 rules down to this firewall. So I get a very scale out model at basically 20 gigs firewall per host. If I scale that out to 50 hosts in the data center, I've got 1 terabyte of east-west capacity. So I mentioned we have this broken architecture, right? Where we have this centralized security service. The problem is scale, right? There's no way that I can take that 1 or 2 or 3 centralized devices and scale that enough to provide the performance needed to secure each VM in the environment or each workload in the environment. So we need a distributed model of doing that, just like we take distributed compute systems. So we have problems that not one server can handle, right? We send them to these high performance compute centers, we run them across hundreds of processors, thousands of processors, and we get results out of these big problems. We need a distributed security architecture as well in order to handle the needs of the data center security as a whole, not just at the point that it ingresses or egresses. So now, do you guys use the agentless secure host introspection with VCNS or with NSX? No? So I can pull the agent off of an operating system, right? So I can run McAfee agents or Symantec agents or Trend agents, right? So it's a good idea. However, there's definitely performance hits here. Has anybody ever had problems where, McAfee is consuming all of your resources on a server and now your application is dragging, right? So obviously if I pull the agent off of there, the other problem with that is an agent-based or an OS-based agent, basically malware has to get onto the OS first before it can be detected, right? So it's like putting an alarm inside your house, not at the front door, right? Or having a secure perimeter around your house or a security gate. Someone has to get into the house before the alarm goes off. The other thing is the first thing malware is going to do is turn that agent off, right? So basically we're able to take endpoint protection or AV scanning, make it transparent to the operating system, right? So actually scan from outside through the hypervisor and share that with whatever platform I use, right? McAfee, Symantec, Trend. I can do agentless scanning with all of those different vendors. I also take my network-based security. Again, keep your perimeter firewall, not telling you to replace that, but I take my network-based security and I pull that up into the hypervisor as well. So I get all of the rich context that I get through an agent, right? What users are logged onto a system, what executables or what daemons are running, what processes are going, any software that's being installed, I can scan. I get all of that rich context. I get very high isolation, and I get it all in that platform, right? Where I'm also delivering my network services, allowing me to span across, different geographies. Pretty large partner community. There's one that's missing. Right? So no Cisco integrations yet as far as security goes. They're coming around though. So it's never been our intent to not work with Cisco. It's definitely been Cisco's intent to not work with network virtualization. If you guys think back to the first days of server virtualization, did Dell run around and tell any of you guys that, hey, this is a good idea, you should get on board? Right? Did HP or IBM or anyone tell you that you really need to jump on the server virtualization train now before it leaves the station? So Cisco's not touting the benefits of network virtualization either. So, but they're coming around. So Chuck Robbins has softened the stance. John Chambers famously said that as far as NSX goes, right, Cisco was going to wipe the floor with VMware, and now Chuck Robbins is telling investors we're looking for ways to integrate more with NSX, right, and take advantage of some of the offerings. And so you'll see more integrations coming. Here's an example with Palo Alto, right? So NSX firewall is layer 2 through 4 only, right? It doesn't offer IPS, it doesn't offer deep packet inspection, it doesn't offer DLP, right? It doesn't do all of the things that those advanced security vendors do. And this works with Checkpoint, it works with Fortinet, right? Lots of different vendors this works with. But basically we can spin up that Palo or that Fortinet or that Checkpoint firewall, and we can selectively choose which traffic needs to go through it for enforcement. So let's say this is my PCI web server. You guys have PCI environments or regulations? Yeah. Again, it could be anything. It could be HIPAA, it could be NERC, right? But the idea is if this is a PCI workload talking to a non-PCI workload, then I want to send that traffic through some other third-party device for IPS services. If it's PCI to PCI, let it go. If it's PCI to non-PCI, I just want to steer that traffic over there and allow this device to provide the next-gen service I need, right? So now, applications can live anywhere in the data center on any piece of compute resource. They're properly firewalled. They've got next-gen services where applicable, right? And if you guys are running separate stacks of compute today in order to meet different, regulation environments, right? So I have maybe a PCI cluster, or I have a CGIS cluster, or CGIS physical infrastructure. You're really giving up. You're maintaining a lot of extra overhead, giving up a lot of excess resources in order to maintain those separate stacks for security purposes. So what we see with a lot of customers is when they deploy this, they start to move all of those into a single stack of physical resources. And they actually are able, in some cases, to reduce their host count, reduce their vSphere licensing count, right? Actually get some operational savings based on the ability to make better use of their existing resources. So, another quick example here. In this case, we're going to integrate some third-party AV solutions, right? So, I've got these web servers here. They've got a distributed firewall attached to them, and the firewall policy is defined by a security group, that being this web tier security group. So all of these VMs get that web tier policy applied. In this case, I'm going to say Trend comes along, again, Symantec, McAfee, lots of different companies we work with, and finds some malware on these guys. So it can actually send an API call back to vCenter, insert a security tag that changes these from the web tier security group now to they're in a quarantine zone security group. When I do that, it's going to change the firewall policy. So now I say maybe these guys can only talk to remediation tools. Web servers, you can no longer talk to app servers. You can only talk to remediation tools now. And at the same time, I'm going to turn on Fortinet or Checkpoint or Palo, right? And I'm going to say, by the way, all traffic in and out of this guy now is going to get IPS, right, or deep packet inspection. Because I know I have an infected system out on my environment, so I'm going to send everything through that next-gen firewall. So based on what Trend finds, I can actually change the checkpoint posture of a VM. And I can do it right where it sits. I don't have to re-IP it. I don't have to move it to a new VLAN, right? I don't have to do any of those things that you normally have to do to affect the security policy of a VM. I just do it through a software definition of what that policy should be. Once they're cleaned, I scan them, I remove them, and they're right back in. right? So I can use NSX as an orchestration and automation tool for different security vendors to work together in your environment. So basically now, again, no matter where they live, no matter where they go, no matter what I find, right, I can apply the policy that's appropriate to that VM where it sits. So I'm just going to give you a couple of use cases here, right? So this is a pretty common setup, right? I've got a DMZ firewall. I've got a DMZ VLAN inside that firewall. I've got another inside firewall with an app VLAN, a database VLAN, and some services VLAN. I deploy my finance application, and it looks like this. So I've got a DMZ instance of my finance for the front end for users. And then, you know, I've got my application and database servers are protected by my inside firewall. I take this and I replicate this now for my HR application as well as for my PCI app, right? And this is a pretty common setup, right? The problem with this is, you know, what happened here with the WannaCry, right? Basically, once one system gets infected, it tries to spread across TCP 445 to all of the systems. And it's going to start by doing that across its local layer 2 segment because, again, there's no security controls within a layer 2 domain in a typical setup. So generally speaking, in this, I did a talk at Region 11 as a ISD service center down in Fort Worth. So they service all of the school districts in that area. They got hit about 1.5 years ago with a crypto locker. And this is exactly what happened to them. Their DMZ, one system got infected. It spread across the entire DMZ, but the inside firewall kept it from spreading, you know, internally. Thank goodness. They detected it before it spread inside that firewall. But every application was down, right? So they were down for about 5 days before they got all their applications back up and running and restored from backup. They had no run books, right, to bring applications back online. It was a big fiasco. And they did a roundtable and talked about basically what happened, but this is exactly it. All right, so I can create some sort of a vertical isolation between applications. I can do this with like multiple DMZ VLANs. I'd have like a finance DMZ VLAN, an HR, a PCI, right? I can go that route. The problem with that is still that finance 1 gets infected, finance 2 gets infected, right? So I've limited the scope a little bit, but I still have the same problem. With NSX, through the use of security groups and the distributed firewall, I can create a finance security group, an HR security group, and a PCI security group. And because I have a firewall that runs at the VNIC, is there any reason why Finance Web 1 needs to talk to Finance Web 2? Right? Generally, there is not. So as long as I create a firewall rule set that doesn't include Finance Web to Finance Web, when that infection happens, I'm actually going to drop that at the VNIC. So I can start to protect workloads through stateful segmentation intra-VLAN. Right? Not only that, I'm also going to apply layer 7 services to this guy now. Right? All of that's done through automation. And that's a brief summary of everything I just said. We talked about View, right? So it used to be that customers didn't want to go to virtual desktops or to this virtual application delivery because it wasn't secure. Right? But now people are actually doing it because it's the most secure way to deploy applications out to your end users. It protects your data center from your users. It protects your users from each other, right? So in this case, I've got some users coming in across the internet. They're hitting their View desktops. In this case, I've got different pools, right? I'm not using the cool app volume stuff. But I've got some security and connection servers. I've got an Active Directory tie-in. Right? And then I've got my enterprise apps as well as internet-based applications in the background. So these are all things that your users, even coming in through View, still need to access to, right? So how do I secure this? Well, I secure it with NSX on the front end by creating what we call edge firewalls. These guys provide a kind of a north-south firewall for end users coming into the DMZ. I can do load balancing of my connection servers. I can do SSL offloading, SSL VPN. I can NAT my internal addresses so that they're not visible to the external world. All those features and functionality available through NSX. I can use user-based controls here on my pools. So when Mary logs in, her Active Directory ID is tied to this front desk pool, and this firewall policy is going to be tied to her Active Directory user ID. So, you know, she can get to the scheduling app, but she can't get to patient data. And if she tries to access a patient data system, it's not that she doesn't have a login for it. It's that we're actually going to drop her packets right there at the VNIC inside of her VDI pool. All right, that packet doesn't even have to make it into the data center before it gets denied. I'll drop it where it sits. Obviously, we talked about how we use distributed firewall to protect enterprise applications just a minute ago, right? Kind of go back to use case one. I can also insert all of those services that I talked about into the VDI pool. So if I want to do antivirus, if I want to do DLP, if I want to do vulnerability scanning, I can choose the vendor that I want and then insert those services into the hypervisor through that guest introspection that I talked about earlier. Right? And when my users go out to internet-based applications, I can make sure all that runs through a next-gen firewall. Right? And again, I do that in the hypervisor before they have a chance to spread anywhere else in the network. So it's pretty complete end-to-end security for your end users and how they're accessing your applications. And when you factor in AirWatch into that as well, right? So we've got the leading mobile device management system on the market. I can create security policies as well for users that come in through AirWatch devices. So it's complete protection, again, from your end users as well as protecting your end users from each other. And that's everything I just said. Multi-tenant scenarios. So multi-tenancy, there's lots of different reasons that you might deploy multi-tenancies. You could create different security tenants, right? So you could again say this is my PCI and non-PCI, and even though they live on the same physical resources, maybe even live on the same VLAN in the physical world, through logical segmentation and logical networking, I can separate them. So I may have different DMZ web servers from different tenants that live on the same host, but they'll never see each other because they're logically firewalled off, right? There's a company down in Dallas. They're called Armor now. They used to be called Firehost, but that's all they do is secure web hosting, right? So they securely host different customers' applications in the web, basically infrastructure as a service, and they use NSX to segment those tenants out. So if this is my customer Coke and this is my customer Pepsi, they might have their VMs running on the same physical server, but they'll never see each other, right? Cross vCenter data center security. So the idea becomes I create security policy once, maybe at my primary site in San Jose. I replicate that policy over to Phoenix, right? And again, now no matter where my workloads live, they get the same security policy where they're at. So if this is a DMZ front-end server in San Jose and I vMotion it over to Phoenix, it's still a DMZ front-end server. It still gets the same firewall policy, still has the same security posture attached to it. Disaster recovery, right? So we talked about network virtualization. So I can have the same IP subnet exist in data center 1 as exist in data center 2. I have the same security policies attached to these VMs. And then when I have an outage, my VMs come up on the remote site with the same IP addresses they had before. So this is another thing that Region 11, the service center, did down there. They used vCloud Air. So, a lot of customers that we talked to are trying to figure out how to do DR. They have a primary data center and then they have a colo. These guys use vCloud Air. So basically they replicate all their storage up to vCloud Air and they pay only for the storage space. They use NSX on-prem in order to define their security policies. NSX extends up into vCloud Air, so they have the same IP space available in the cloud. And if they have a DR event, then all of their compute workload just comes up via SRM inside of vCloud Air. Right? And they only pay for the compute resources if they run for more than 30 days. So as long as they recover in 30 days, this is no cost to them, except for basically paying for the storage. And then this is the big one everybody likes to hear about. So if you guys aren't familiar with the VMware cloud on AWS, worst kept secret in the world was that we were going to do a partnership with AWS. Everybody kept asking about it, and we kept not commenting on it. And so eventually, right, we just went out and made it public. We made it public way earlier than we should have, but it's coming. So I've got actually one of my customers is in the Lighthouse program, so they're running production workloads in AWS today and using NSX to extend that up to AWS. The idea becomes, though, basically what you're going to do when this becomes available, VMware Cloud on AWS, is the full software-defined data center stack running in Amazon. You'll actually go into My VMware portal. You'll provision bare metal servers in Amazon. You get vSphere, NSX, vSAN installed on those bare metal servers. And you'll manage all of those resources through vCenter just like you did today. So there's no EC2 platform, right? No Granite and all of that stuff. It's all run using the software-defined data center stack. I can then take my applications and I can have cloud-native applications, right? These guys just live in Amazon. They're on a logical network that doesn't extend down to the data center, right? They'll always live in the web. These guys will always live on-prem, right? So maybe if these are, tier 2, tier 3 apps, that if I have a DR event, they can be down for a week, right? But then I'll have some applications that live on these universal logical switches, these universal layer 2 segments that span both, right? And if I vMotion VM1 up to AWS, right, he keeps the same IP address, he keeps the same security policy, and I can even do that between clouds. So with AWS and SoftLayer, if I'm using both of those, I might vMotion this VM up to AWS today. Next month I'm getting a better price from SoftLayer to host, virtual workloads in IBM rather than Amazon. So I just vMotion those workloads over to SoftLayer, right? And then maybe later on I want to bring them back into the data center, so I just vMotion them right back. There's no replatforming, none of that kind of thing occurring. It's the same platform across, was that like a notification, or do you have a question?
Can you ask a question?
Yeah, go ahead.
Is there any automation that moves it based on costs that you might get at Azure or AWS or software?
Yeah, so is there automation that can take advantage of, costs that you might be receiving from different providers? And absolutely. So vRealize automation or even an OpenStack implementation could easily manage resources across both clouds. We've got vRealize, what is it, Business Manager? Is that it? vRealize Business, yeah. So that'll provide basically a cost basis for VMs to run in your data center, in Amazon, in SoftLayer, your different cloud providers. So you could automate that whole thing, right? You could kick a report off on the 30th of each month that says, where am I getting the best prices, or on the 1st of each month, right? And just have vRealize automatically reprovision your workloads to the lowest cost provider. So, good question.
Can you be a
Follow on?
in your on-prem be set up as a provider
Sure, yeah.
and the cost applied?
Yeah, so you can compare, what am I paying on-prem in data center 1? What am I paying on-prem in data center 2, right? If I've got different geographic locations, different data centers. What am I paying in AWS? What am I paying in SoftLayer? And by the way, reprovision resources as it becomes most cost effective, and obviously as I have resources available. I can't move everything into data center 1 if I only have enough resources in data center 1 to host half of my applications. But based on resource availability, I could certainly kick off an automation process that would reallocate my resources where they can be reallocated based on the lowest cost. And with SoftLayer and AWS, if that's where I'm getting my best cost, provisioning more resources in AWS is just a matter of automation as well. I need more bare metal servers, right? So I get the scalability and the elasticity of public cloud providers. Most of the public cloud providers now, it's basically a race to the bottom on pricing. So each one of them is getting cheaper and cheaper and cheaper and cheaper, especially as they kind of become more commoditized. So yeah, I'll be able to take advantage of those benefits. Then I've got a reference white paper for you. So if you guys will memorize this URL, and when you get back to your offices or tomorrow morning, just pull up your memory and go back and type that in. Or Google NSX Rackspace PCI, might be an easier way to do that. So basically they had a problem, they had a mixed mode environment. PCI, non-PCI systems existed on the same VLAN, existed in the same hosts. That did not meet their auditor standards, surprisingly, right? So there's two options. So how do I normally take care of an issue like that? I take one of those applications, I completely re-IP that application, I move it to a new VLAN behind a security device that'll provide the security that I need whenever I ingress or egress that VLAN. That's problematic because I'm going to break that application, right? There's going to be host files and static bindings, and it's not 100% DNS based. You're also going to have to fight with your application owner, right? Hey, I'm going to re-IP your application. No, you're not. Re-IP the other application. The other application, no, re-IP their application, right? So yeah, so if you guys have been through an exercise like that, it's not simple. So what Rackspace did is they took option 2. They'll go with the software-defined solution, all right? So they used NSX in order to create that segmentation. Normally I don't read slides out. I hate people that do that, but I'm going to read this quote off here. This is from Luke Huckaba. He's a principal architect down at Rackspace. So he said, we used NSX to microsegment the environment, specifically to isolate the PCI systems and non-PCI systems. He says nothing can talk into those PCI systems unless they're explicitly allowed to. We're able to isolate the PCI systems from the rest of the environment Here's the key: without having to re-IP anything or physically change any networking. All right, there is no other way to do that. There is no other solution on the market that provides the ability to re-secure all of your workloads in place where they sit today, same IP, same physical servers, same physical network. All right, we are the only software-based solution to that. So that's all I got. Any questions? 4 o'clock, right on the dot. Good? Yeah. Thank you.
I'd also like to thank the Pinnacle team who was able to attend and all of our customer base. We really appreciate you guys coming out. There were a few questions there at the end around automation, and if you guys ever want to hear more about vRealize Business or vRealize Automation, please be sure and hit us up. It's something that we've built an entire practice around, and we really thank you for coming today. So enjoy, and we'll see you next time. Thanks.